Welcome to the overview of our pack number 2. Let's start with all formulas, presets for Octane and Cinema 4D. I'm running the latest Octane version for Cinema 4D. And in this file, all formulas we have, actually all the 4 formulas we did for this pack number 2. And it came with a basic material. So you have 4 different materials, all based on iteration number. So let's start from the first one. This one is called Menger Koch, and it's a really cool formula. We've added a lot of parameters, so you can change the angles. You can make this loop, of course. Then there's really a lot to play with here. At first, maybe it's scary, but take your time and just start playing with parameters. Then you will understand how it works. Or you can just explore without understanding what you are doing. Then we added some modes. So like Bismuth. This will create a huge box. And this is defined, the size of this box is defined by the bounding box in the object parameter, so you can increase or decrease that. And of course you can still play with the angles or the offset. And of course also you can change the colors on iteration. And just combine more mod. So this is the first formula. Then we have a folding broad formula. This one, I love this one, it's one of my favorite. It looks really organic, but you can also make like structural things. And also here there's many different parameters. One of my favorites is actually set the box fold to 2, so you get this kind of plane. If you disable that and set that to 0, you will get just a sphere. And because the Julia mode is enabled, if you disable that, you will see the Mandelbrot set actually in 3D. And I can show you the Mandelbrot set. So if you change the bounds to 100, even less, like 10, here you can see your Mandelbrot set. And of course you can play with the parameters. So you have perturbation parameters, you have angles, more angles, the Julia mode and Julia mode parameters, the box fold. There's really a lot to play with. Of course you can zoom in. And this is a really cool formulas. So let's go back. You can loop the angles to create an abstract loop animation. But we will see all these formulas in depth with a singular tutorial for each one. So let's go to the next one, the Uber bulb. So at first this looks really similar to the classic Mandelbrot formula, and actually it is, but we've added many different parameters so you can tweak really everything. So the standard bulb is with a power of 8. Let's enable the color back again, and you can loop the animation. You can tweak the explode parameter or implode. Then we've added 2 different modes, so the cylindrical mode and also the negative cylindrical. But if you combine those two, you will see that you have an infinite corridor made out of Mandelbrot fractal. Of course, there's a cut in here. That's always because of the bounding box. So if you increase that, it will be wider. Let's disable that. Then there's angles. Of course, you can create a loop also for this one. So let's say, for example, that you like this spot, and you can change the angle and make it loop every 360 degree. Then, as always, there's the Julia mode, which if you enable the Julia mode, you will see that the Mandelbrot set is just a sphere, but if you change the Julia mode, the fractal pattern will emerge. Then we've added the Brot mode, so you can change this to like virus, which will create this this spine-looking shape, which is really interesting. And there's different modes, so virus 1, virus 2, and then rings. This is really strange, but sometimes it can be useful. It looks good. And then we've added a fractionary mode that sometimes gives you the look that you are looking for, combined with other parameter. Then the radius, which is not the radius of the fractal, so it's not like the bound box. It's more a radius at a fractal level. Also kind of difficult to explain what this does. And the center of the radius, so if you set that to minus, you will see that the fractals start to translate. And then, of course, the color parameters. And at the beginning of the parameters, there's all the thing that you need to optimize and fix bad holes in the fractal, like the bailout. You see that if you increase the bailout, you will have longer, you will have basically more detail. So if you decrease that, less detail, and increase more detail. But let's go to the other one, to the last one, the Huber-Sierpinski, which is my favorite of all formulas here, because it can be both organic and hard surface looking. So in this case we have organic presets, always with colors based on iteration. And I think this is the formula with the most parameter of all. There's rotation, like always, and different kind of rotations. Then there's the scale of the Menger, because this is actually a Menger. If you are familiar with fractals, is a Menger box. So if you reset and compile the Vectron code, you will just set to default all the values. And as you can see here, we have a Sierpinski triangle, which is of course infinite. And then you can just decrease the array epsilon, and more triangles will appear. But this fractal actually is it's very similar to the Menger sponge. It's just with one side less. So you can tweak also individual scales for each axis. And just play with that and see what you are doing, and the effect that each parameter has on the fractal. There's the offset, and of course angles. When you play with angles in this formula, you will see more organic shape. Like here we already have a tree looking, root looking shape, which is really cool. Let's reset the angles. Then there's a box fold option. This is maybe the most cool option of this formula, because it really changed how the fractal look. And there's also mode, full fold mode. This will make like a more symmetrical fractal. Inverse cylindrical, this is like the Huber bulb mode, where you have an infinite corridor made out of the same fractal. And of course with the inverse cylindrical mode you can still tweak anything else. So there's also this option. Then sin X, and you can tweak the strength of the sin X. Sin Z, you can enable all together also. So maybe it looks boring because I've not been lucky with parameter tweaking now, but you will see then later in depth I will look for something that looks like a a city, and we are going to make a procedural shader for our city with colors and materials based on iteration, as you can see here. So we can map one material on this color and another material on this other color, and it will be fun. So this is the overview of our 4 formulas